Hi, my name is Megan, and in today's video we're going to be discussing worked examples, which are step-by-step demonstrations of how to solve a problem or perform a task. You've likely encountered worked examples as they are a common teaching and learning strategy during the initial acquisition of a skill. It's incredibly useful to students when using worked examples the first time they're learning a concept. So now that you know what a worked example is, we're going to solve two problems, the first of which will be a quantitative worked example. And for this, we're going to solve an algebraic word problem, which says that a painter took 162 minutes to paint a wall that was 8 meters squared in size. So 162 minutes, 8 meters squared. If she paints at the same speed, how long will it take her to paint a wall 12 meters squared in size? All right, so the first step for any worked example is to pull out the information from the problem that you already know. And in this case, we already know that for a wall that was 8 meters squared in size, it took her 162 minutes to paint it. So 8 meters squared in this case equals 162 minutes. In order to find out the amount of time it would take her to paint 12 meters squared in size, we first need to determine how long it took her to paint just 1 meter squared. So in order to do that, we're going to divide both sides of the equation by 8. So 8 divided by 8 and 162 divided by 8. And that shows us that for 1 meter squared in size, because 8 divided by 8 is 1, it took her 20.25 minutes, because 162 divided by 8 is 20.25. So now we know 1 meter squared took her 20.25 minutes. But what do we need to find out? We need to find out how long it will take her to paint a wall that is 12 meters squared in size. So we do a basic multiplication problem from this point on, and we multiply both sides of the equation by 12. So we come down here and multiply by 12. 1 multiplied by 12 is 12. And we multiply the other side by 12 as well. And we see that 20.25 multiplied by 12 is 243. So the very final step of this problem shows us that for a wall that is 12 meters squared in space, it will take the painter 243 minutes to paint it, which is the answer to our original problem. So just to reiterate, we first pulled out what we knew from the equation. We divided both sides by 8 in order to find out how much time it would take for just 1 meter squared. When we determined how much time that would take, we multiplied both sides by 12. And then we arrived at our final answer, which is that 12 meters squared is equal to 243 minutes. All right, so we just discussed what a quantitative worked example looks like. Now we're going to go over what a qualitative or non-math worked example would look like. And today's example is going to be the scientific method. So there are 5 general steps to the scientific method. The first is to make an observation. The second is to ask a question related to that observation. The third is to form a hypothesis, the fourth is to perform the experiment, and then the fifth is to analyze your results. So for the purposes of today's example, or today's worked example, we're going to make the observation that plants seem to grow taller in fertilizer. So plants grow taller in fertilizer. All right, that's our observation. So the second step is to ask a question about our observation. And so the question in this case would be, which fertilizer makes the plant grow the tallest? So which fertilizer makes the plant grow tallest? All right, and form a hypothesis. So in this experiment, we're going to have a control, which is a plant that doesn't have any fertilizer. Just as a comparison, we're going to have ammonia sulfate as a fertilizer and ammonia nitrate as a fertilizer. And my hypothesis is that plants will grow tallest in ammonia nitrate fertilizer. So plant will grow tallest in ammonia nitrate. So perform the experiment. So we'll have our plant that serves as the control. We'll have our plant potted in ammonia sulfate, and we'll have our plant that's potted in ammonia nitrate. So perform the experiment. So each plant's going to receive the same amount of water, the same amount of sunlight. The only difference is what type of soil and or fertilizer they are potted in. And let's say that over a 2-week period, the control grows 1 inch. The plant potted in ammonia sulfate grows 4 inches. And the plant potted in ammonia nitrate grows 2 inches. Well, from this data, we would analyze our results to see which plant grew the tallest under which fertilizer. And it's very evident that ammonia sulfate was the fertilizer in which the plant grew the tallest. And that was not our hypothesis. Our hypothesis was that it would grow the tallest in ammonia nitrate. So we disproved our hypothesis in this worked example, but we showed that ammonia sulfate serves as the better fertilizer for plant growth, which was our question. Which fertilizer makes the plant grow tallest? This is an example of a qualitative worked example. And again, just like quantitative, as the student, you would perform this type of problem. And then as you grew more comfortable with solving problems like this, the amount of instruction or the amount of work that you would have to use as an example throughout your worked example would hopefully decrease over time until you're able to perform the entire problem independently. So now that we've gone over examples of what both quantitative and qualitative worked examples look like, let's summarize what we've learned overall. Number 1, any type of problem that is solved in a step-by-step process can be learned using worked examples. Number 2, worked examples are effective for quantitative problems such as physics math problems, engineering problems, and qualitative problems like the scientific method we did in today's example, or research or analytical papers, case studies, etc. Number 3, the overall process of a worked example is identifying and then explaining the what and the why for each step of a problem as you're learning how to solve it on your own. It provides a sort of support that you can lean on when trying to remember how to go from the beginning of the problem to the end of the problem. And then eventually, hopefully, being able to fade out the amount of support you need to solve the problem until you're comfortable enough to solve it from beginning to end independently.